Hello everyone, myself Snehanjan Acharyya, a senior research fellow at Advanced Technology Development Center in Indian Institute of Technology Kharagpur, is going to deliver a presentation on our paper, that is Discrimination of VOCs along with concentration change detection applying a combination of DWT and machine learning tools, having a paper ID 1581. So this is the outline of my presentation. So in this work, we have mainly focused on the selectivity issue faced by semi-conducting metal oxide based gas sensor. In this work, we have synthesized tin oxide, it is SNO2. We have done its material characterization, then finally employed that as a sensing material for our gas sensor and carried out the gas sensing study. From the transient response, we have extracted features using discrete wavelet transform tool, and finally we have employed the features to the machine learning algorithms we have developed to discriminate between different VOCs and also the concentration to detect the concentration change in between the transients. On a daily basis, we frequently encounter different types of harmful, toxic, flammable gases depending on the field of activity, and that may impact on our health and well-being. So, proper monitoring and detection of these gases is of utmost importance. So, different gas sensing methods have been developed in past and have been exploited by the researchers, namely listed here: chemiresistive, optical, electrochemical, chromatograph, acoustic, thermal. So here we have uh, primarily focused on chemiresistive based gas sensors. Now, semiconducting metal oxide based gas sensors offers several advantages as listed out here. It has also some limitations. Among them, poor selectivity is of prime concern due to its cross sensitivity to different gases. Now, various methodologies have been adopted in past by the researchers to achieve selectivity. Pattern recognition is most recent and have gained immense attention throughout the research community due to its success. In this work, also we have adopted different soft computing tools to achieve selectivity through pattern recognition techniques. In conventional gas sensors, the transient response corresponding to variation of concentration of any gas shown with subsequent response and recovery curves one after another. However, considering the real-time scenario, the concentration of any particular gas or VOC might vary without any recovery, and the transient may abruptly change from one concentration to another, obviously on introduction of that changed concentration. Hence, it is important to recognize the concentration change and to distinguish among different VOCs selectively to mimic a real-time practical situation. As I have mentioned earlier that we have utilized SNO2 as a sensing material. So particularly we have synthesized SNO2 hollow spheres using simple hydrothermal technique. The process steps are displayed here. So we have used tin chloride dihydrate, sodium citrate, NaOH to make the solution, and then added PEG 600, then stirred vigorously for 30 minutes. Then the final solution was transferred to Teflon lined autoclave, and which was kept at 180 degrees Celsius for 24 hours. And the final product we have obtained is calcined at 450 degrees Celsius, which was used for making gas sensor and taking the gas sensing study. So here are different material characterization study we have carried out for our sensing material. So FECM image clearly shows the formation of well-defined hollow sphere structure. Then the X-ray diffraction pattern shows the crystallinity of the material, from where we have inferred that the formation of tetragonal structure with rutile phase of SNO2 and different lattice planes corresponding to SNO2 and SAD pattern also confirms the formation of our desired material. The fabrication of sensor device was carried out over a ceramic substrate having gold-based interdigitated electrodes, over which we have deposited synthesized SNO2 hollow spheres. The gas sensing measurement was carried out in a custom-made gas chamber having heater arrangement with temperature controller, and the contacts were made over the sensor device, which were taken to the source measure unit. Each target VOC, which was kept in a liquid phase, was passed through a bubbler system
using synthetic dry air. The desired concentration of VOCs was achieved by using two digital mass flow controllers. So whole arrangement of gas measurement system has been displayed over in this schematic of gas sensing setup. The gas sensing behavior was studied towards formaldehyde, propanol, toluene, and methanol at four different concentrations. The sensor was operated at different operating temperatures. So it is clearly evident from the response values that the sensor is sensitive towards all the VOCs and not selective at all. So the transient response was recorded in a fashion that there was no recovery. The concentration was varied from low to high ppm, and the change in concentration was followed only after the saturation. Now, considering every possible low to high concentration change, there can be six combination as shown in the figure on the left hand side for formaldehyde at 250 degrees Celsius. So from the figure, it is evident that for transient, there is a abrupt change in the transient on introduction of higher concentration. So in real time scenario also, this is to be detected. So our objective is to detect successfully this change in the transient. So discrete wavelet transform is an efficient tool to detect these abrupt changes in the signal. So here we have applied Haar wavelet as Mather wavelet function with 5-level decomposition, which was found out empirically. So in the figure on the right hand side, you can see the detail 4 and detail 5 contains maximum information with clear distinction. So these coefficient values were taken as features. Also, there were 4 VOCs. So considering all into account with all the combination of concentration changes, there were 96 transient curves, which were also transformed using DWT technique, and uh, the dataset was formed having 96 measurements, so which were fed to the machine learning algorithms.
Different machine learning algorithms were employed as supervised learning process over the dataset we have generated from the feature extraction through DWT. Here we have employed random forest, support vector machine, and multilayer perceptron. The random forest is based on ensemble learning strategy which creates multiple independent decision trees and combine their results and take the majority decision to make the final prediction. For support vector machine, the algorithm attempts to distinctly classify the data points by constructing a hyperplane with maximum distance between the support vectors. And the optimal hyperplane provides the best separation of the data points, obviously which were tuned using hyperparameters. Multi-layer perceptron, or in short MLP, is a neural network kind of algorithm having a feed forward and back propagation loop with layered architecture. Here we have uh, utilized these optimum hyperparameters for our algorithms, which were found empirically. Now coming to the final part of the work, that is classification and detection of VOCs by machine learning algorithms. So the extracted features obtained from the DWT analysis were used as input information which were fed to machine learning algorithms. So to test the rationality and robustness of our data set as well as the algorithm, we have applied 12-fold cross-validation technique over the data set, and this whole task was divided into two parts. That is, first the discrimination task, that is to identify among different VOCs, and the next task is to detect the concentration change among the transients. So in first task, as it is evident from the figure here, so we have achieved 100% accuracy for some of the data set with an overall accuracy of, means average accuracy of 96.35% for random forest, which is the best case. Then thereafter we have achieved 92.71% for MLP, and for 91.67% average accuracy for SVM. So this shows that we were able to successfully discriminate among different VOCs, considering all the data measurements into account. Next, we have since RF was the best was showing the best accuracies, so we have taken RF algorithm further, which was trained in such a way that the low concentration is known to the algorithm and next concentration change is to be detected. Again, we have used the same features we have obtained from the DWT, and there we have achieved average accuracy for different VOCs as mentioned here. Like for formaldehyde, it was 93.75%, methanol 94.67%, propanol 92.29%, and for toluene it is 91.45%. So this data shows that it was an acceptable accuracy, and we can strongly say that we were able to classify and detect the concentration change of the VOCs accurately. For this work, I would like to acknowledge Central Research Facility at IIT Kharagpur for various characterization support of our synthesized material. Then also I would like to thank Science and Engineering Research Board (SERB) for partial financial support of the work under the project IAQ. Thank you everyone for listening. Also, I would like to thank IEEE Censor Council and all the committee members for organizing this conference.